Good afternoon, sir. My name is Prakhar Patwardhan, and I am here to present my EL of Robust Design course code 21ME78, and my title is Swan Optimization in Gear Design. So these are the content of my PPT which I have made. So I've done the Python code. So I've shown the code in the next slide, which at end I'll show the code to you. And these are the content which I'm showing: importance of swan optimization, types of swan optimization, in swan optimization gear design, and factors affecting gear design. So coming to the introduction of the PPT, so swan optimization algorithm stimulate self-organized behaviors found in nature to search for optimal solution efficiently. These algorithms involve multiple agents that work collaboratively to explore and exploit the solution space. So key characteristics of are simple rules, complex behavior. So each agent follow basic rules, but the collective achieves an optimal result. Second point is collaboration communication. So agents share information to improve solution. Third is self-organization. So the system adapts dynamically. Fourth one is decentralized control. So no single entity governs the process. So this is the basically the picture showing swan optimization. So coming to the importance of swan optimization, the first one is scalability and parallelism. So this can handle large data sets and multi-dimensional problems efficiently. Uh, this works well with distributed computing and parallel processing. Third one is no need for gradient information. So unlike traditional optimization method, swan optimization does not require derivative information, making it useful for non-continuous or non-differentiable problem. Third one is adaptability and robustness. So it works well in dynamic and uncertain environments. Self-organizing nature makes it robust to changes in the problem space. And the last one is efficient problem solving. So it finds near optimal solution for complex, non-linear, and high-dimensional problem. So which is suitable for problems where a traditional mathematical model fails. So I'll now explain the types of swan optimization algorithm. So the first one is particle swan optimization, which is PSO. So it is inspired by bird flocking. Second one is ant colony optimization, which is ACO. So it is modeled after ants finding food. Third one is artificial bee colony, ABC. So which mimics bee foraging behavior. Fourth one is firefly algorithm. So this is inspired by firefly's attraction mechanism. Fifth one is bat algorithm. So based on bats equation for navigation. So coming to the ant colony optimization. So I'll now explain what is ant colony optimization. So ant colony optimization, which is ACO, is a nature-inspired optimization algorithm developed by Marco Dorigo in the early 1990s. So Marco Dorigo developed this. It is based on the foraging behavior of ants. And so basically the communicates using pheromones, leaving chemical trails that help other ants follow the optimal route. So basically there is a main ant and the which leaves the chemical so that other ants can follow the same path to reach the particular goal. Over time, stronger pheromone trails reinforce better paths, leading to convergence towards the best solution. In ACO, a group of artificial ants explore a problem space where each ant constructs a solution by moving through possible choices. The probability of selecting a path depends on the amount of pheromone deposited and a heuristic value, such as distance in routing problem. Now, coming to the applications of ACO. So, network routing, optimized data transmission paths. Second one is logistics and supply chain, which finds the most efficient delivery routes. Third one is vehicle routing, which helps in planning optimal travel paths. Fourth one is scheduling problems, schedule using job shop scheduling and resource allocation. Fifth one is bioinformatics, which is applied in DNA sequencing and protein structure prediction. Now coming to what is particle swan optimization (PSO). So particle swan optimization (PSO) is a nature-inspired optimization algorithm developed by Kennedy and Eberhard in 1995. So these two guys developed particle swan optimization, and it is based on the collective behavior of social creatures such as bird flocks and fish schools to find optimal solutions in multidimensional search space. PSO consists of swarm of particles, each representing a potential solution. So these particles move through the search space and adjust their position based on based on their own best known position and a global best position, which is known as G best and P best of the entire swan. The movement of particles is influenced by their velocity, which is updated at each iteration using mathematical formula that balances exploration and exploitation, which is searching new areas and refining good known solutions. So applications of PSO are engineering optimization. So the first one is structural design and circuit optimization. Second is machine learning, neural network uses. So basically, neural network is a branch of machine learning. So in this, we use particle swarm optimization, feature selection. Third one is robotics, path planning, swarm robotics. Fourth one is finance. So portfolio optimization, stock market prediction. Can use in this health care and bioinformatics. So disease diagnosis, medical image processing. We use this particle swarm optimization. So coming to swarm optimization in gear design. Swarm optimization techniques such as particle swarm optimization (PSO) and ant colony optimization (ACO) have been increasingly used in gear design and optimization to enhance performance, efficiency, and durability. These algorithms mimic the behavior of natural swans to find the best design parameters, reducing weight, improving strength, and minimizing gear failures. So the key objectives of geared optimization are minimizing weight, so reducing material usage while maintaining strength, maximizing strength, so enhancing gear durability and load bearing capacity. Third one is reducing friction and wear, so optimizing tooth profile to improve efficiency. Fourth one is improve efficiency, so minimizing energy loss due to transmission error. And the last one is noise and vibration reduction, so optimizing gear tooth modification to lower operational noise. So coming to the factors affecting gear design. So these are the factors which affect the gear design. So the first is design parameter. So these are the factors which in design parameters are, the first one is module, so which determines the size of the gear teeth and affects the load distribution and strength. Second one is number of teeth. So it influences gear ratios, smoothness of operation and wear resistance. The third one is pressure angle, which is alpha. So typically 20 degree to 25 degree, which affects contact force and efficiency. And the fourth one is helix angle, which is beta. So basically these are used for helical gear. So it impacts noise, smoothness, and load distribution. Now coming to the face width B. So the wider face increases strength but may lead to misalignment issues. Last one is gear ratio, which defines speed reduction or amplification in the system. So these are the design parameters. Now coming to the material properties. So in material properties, the first one is hardness and strength, which determines resistance to wear and fatigue. Example, steel versus plastic gear. Second one is toughness, so ability to withstand impact loads, like examples like alloyed steel gears. Third one is surface treatment, so case hardening, nitriding or carburizing improves wear resistance. Last one, self lubricating material. So this is used in polymer gear for reduced friction and maintenance. So coming to the factors affecting gear design, in the third point is manufacturing and tolerance. So gear tooth accuracy, poor manufacturing can lead to noise, backlash, and reduced efficiency. Surface finish can also be considered here. So smooth surface reduces friction and improve efficiency. Profile modification, which prevents edge contact and reduces stress concentration. The fourth one is operating condition. So load condition, so excessive load can cause tooth bending, pitting, and fatigue failure. Lubrication reduces friction, wear, and heat generation. Incorrect lubrication leads to premature failure. Temperature variation, so thermal expansion affects gear meshing and alignment. Uh, and contamination and debris, so foreign particles can accelerate wear and cause damage. Dynamic factors are vibration and noise, so misalignment, backlash, and improper mounting led to excessive vibration. Shock loads, sudden load changes can cause tooth breakage. Misalignment, incorrect installation affects the contact pattern and increases stress. So these are all the factors. I've explained the five factors that can affect the gear design. So basically, I've written the Python code. So the first is I have imported the libraries pandas, numpy, matplotlib, and seaborn. I have imported the library. I have used the Jupyter notebook to for my Python code simulation. So this is all the Python code which I have shown to you. This is the defining the PSO objective and all. This is the confusion matrix output. Now I'll show the simulation, then I'll come to the conclusion part. So this is the simulation of the Python code which I've written. Now I'll enter the value. This is the Young's modulus for steel. I'll enter the Poisson's ratio, maximum allowable stresses, contact stresses. So this is the confusion matrix that I am getting. So this is the confusion matrix graph which is plotted between true level and predicted level. Now, basically, I've implemented Taguchi and how I've linked Taguchi with a robust design that I'll explain. So basically, first I'll tell the what is confusion matrix. So confusion matrix is in a simple words is a confusion matrix is a table that shows how well a machine learning model predicts things correctly or makes mistakes. So it works on how it so basically it compares the actual result versus predicted result and has four parts which is as seen in the graph. So how is Taguchi is implemented in this? So we are designing a gear that works well even if manufacturing or material properties vary. So in Taguchi method, instead of testing every possible design, we test only a few smartly chosen cases. It helps a robust design that performs well in all conditions. So in particle swarm optimization, which is PSO, so it works like bird searching for food. So each bird, which is a gear design, improves over time. It finds the best gear size, shape, and strength automatically. So why this is used? So it is used to reduce testing time and cost, ensures gears work reliably in real life, and it prevents failure due to small material changes. So coming to what's new in this version. So the first point is Taguchi's orthogonal array. Second is signal to noise ratio, S by N ratio. Third is PSO optimization, though finds the best gear parameter using robust performance matrices. And the fourth one is confusion matrix. So it stimulates a classification problem for robustness validation. So why we should use this? So to ensure stability. So Taguchi's method reduces sensitivity to parameter changes, more efficient optimization. It uses only 9 experiments instead of exhaustive testing, and practical for real world manufacturing, reduces failure rates and improves stability. So this is the confusion matrix and this is the code. So as earlier mentioned, I have installed the library NumPy, Panda, PySwan, and these are the tools which I have imported from the Jupyter library. Iter tools and sklearn from metric for the confusion matrix. This is the sklearn tool. Now coming to the confusion matrix, the output which I have obtained, I'll explain this. So the recommendation that I can get from the output are, so basically I should use a more balanced data sheet, adjust the decision threshold, and use different matrices for optimization. This is the recommendation. And coming to the conclusion part of the video. So in conclusion part, Swan optimization techniques, especially the particle optimization, has emerged as a powerful tool in the field of gear design due to the simplicity and adaptability and computational efficiency. PSO mimics the social behavior of birds flocking or fish schooling, allowing particles to explore and exploit the solution space effectively. So this leads to faster convergence rate and the ability to avoid local optima, which are common challenges in traditional optimization methods. In gear design, where objectives often include minimizing weight, maximizing strength, enhancing durability, reducing noise, and improving efficiency. So this the algorithm ability to navigate complex and non-linear design space makes it highly suitable for optimizing parameters such as a gear tooth profile, module face width, and material selection. So when applied to gear design, the PSO has a demonstrated significant improvements in optimizing gear performance, leading to longer service life. So better load distribution and reduced vibration level. Its population-based approach ensures a diverse set of solutions, which is crucial for balancing conflicting design criteria. And additional PSO straightforward implementation and low computational cost make it an attractive choice for both academic research and industrial application. So compared to other evolutionary algorithm like genetic algorithm or differential evolution, PSO requires fewer parameters adjustment and exhibits more stable convergence behavior. This makes it particularly advantageous in scenarios where quick decision making is essential, such as real-time design, adjustment, or iterative product development cycle. So these are all the research paper which I have referred. So I have researched almost 8 research paper for this. So this is all about my presentation. Thank you.